Hey everyone, in this video, we'll implement a third-person camera that can rotate around the player like this. Alright, so let's start creating it. So let's implement the third-person camera controller. So first, I'll add a capsule to the scene, which we can use as the player for now. Alright, let me name this player. And I'll double-click on it to focus. And let me just place it above the ground. Alright. So now, we want our camera to look at this player and rotate around it, right? So let's go ahead and write a script to achieve that. All right, so in the scripts folder, we already have a script called simple camera controller, but we are not going to use that. We're going to build our camera controller from scratch. All right, so let me go ahead and delete it. And then I'll create a new script called camera controller. All right. So let me get rid of all the default code in the script. And in the script, what we want to do is, first we want to place the camera behind the player at a distance like this. All right. So this is the player and this is the camera. So we want to place it behind the player at a distance. So in the camera controller script, first we need a reference to the object that we want to follow, right? So here I'll create a serialized field variable of type transform and I'll call this follow target. All right. And next we want to place the camera at a distance behind our follow target, right? So in the update function, we can set the position of the camera to follow target dot position minus the distance by which we want the camera to be behind, right? So I'll subtract follow target position by a new vector, and this vector will be 0 in both x and y, and in the z we should provide the distance. So for now, let's say we want the camera to be 5 units behind the player, so I'll just put 5 for the z. All right, so let's go to Unity and see the result of this. So first we need to attach the camera controller script to our main camera. All right, so let me just drag and drop it over here. And then we need to assign the follow target object. So let me just assign the player as the follow target. So now let's go ahead and run the game. All right, so you can see that the camera is placed behind the player at a distance. So we can actually minimize the game view and take a look at it from the scene view. So you can see that the camera is behind the player and its Z position is -5 since the player's Z position is 0. So it's placed 5 units behind the player, right? Just like we specified from the script. So that's working, but it's not good to hard code numbers like this in the code. We should make this a variable and expose it in the inspector so that the designers can easily tweak these values without touching the code, right? So let me create a new variable for that. All right, I'll make it a serialized field so that it's exposed in the inspector. And this will be a float variable. And I'll just call it distance and set its value to 5 by default. Okay. So now in here, instead of hard coding 5, I'll use my distance variable. Okay. So now if you go to Unity, we can change the distance value from the inspector, right? So let me just put it back to 5. All right. So now we are placing the camera behind the player at a distance. So next, we should rotate the camera around the player when we move the mouse, right? So we should rotate the camera both horizontally and vertically. But first, let's handle the horizontal rotation. So how can we rotate the camera around the player like this? So for that, all we have to do is just rotate this vector, right? So this is that vector. And if we rotate this vector by multiplying it with the rotation, then it will be rotated like this based on the angle. So let's go ahead and try this out in Unity. So to rotate a vector, we just have to multiply it with a rotation. So let's say we want to rotate this vector by 45 degrees. So for that, first we need to create a rotation of 45 degree. So I can do that by using Quaternion.Euler. All right. And in which axis should we rotate it? So the rotation here is horizontal, right? And if we want to rotate something horizontally, then we should rotate it in the y-axis, right? So in the Quaternion.Euler, I'll put 0 for the x, 45 for the y, and 0 for the z. So this will create a rotation of 45 degree in the y-axis. And then to rotate this vector, all you have to do is just multiply this quaternion to this vector. All right. And this will rotate this vector by 45 degrees. So let's go to Unity and see the result of this. All right, I'm going to play the game. So now you can see that the camera is still behind the player, but now it's at a 45-degree rotation, right? So this will be more clear if you look at it from the scene view. All right, so if I just go to the top view in the scene, you can see that the camera is placed behind the player at a 45-degree angle. All right, so that's working as expected. So next, we want to rotate the camera around the player like this when we move the mouse horizontally, right? So that is pretty simple to achieve. What we can do is we can create a float variable over here called rotation y, and then in the update function we can add the mouse x input into the rotation y variable. All right, so I'll say rotation y plus or equal to input dot get axis mouse x. All right, so we'll be adding the joystick in the future, but during the implementation, let's keep this simple and use the mouse. So now in the Quaternion.Euler, we can use rotation y instead of just hard coding 45. All right, so let's go to Unity and see the results. So you can see that as I move the mouse, the camera is rotating around the player, but right now it's not looking at the player, but it's still rotating around the player. All right, you can get a better view of it from the scene window. Okay, so yeah, you can see that the camera is rotating around the player in a circle. Okay, so that's working fine. So next, we should make the camera look at the target when we rotate around it, right? So that's pretty easy to achieve. All we have to do is set this rotation as the rotation of the camera. All right, so first let me store this rotation into another variable so that we can reuse it. So I'll call this variable target rotation. All right, and here I'll multiply the vector with the target rotation, and then we can also set this as the rotation of the camera. So I'll set the transform dot rotation to the target rotation. Okay, so now the camera should also look at the player. So let's go ahead and test it. All right, So now you can see that as we rotate around the player, the camera is constantly looking at the player. So that's working. So now we are done with the horizontal rotation of the camera. So next, we should also rotate the camera vertically like this, right? So this is going to be just like the horizontal rotation. The only difference will be for vertical rotation, we should rotate it around the x-axis. So here, I'll create another variable called rotation x, and then we should rotate the camera vertically when we move the mouse up and down, right? So to the rotation x, I'll add the mouse y input. All right, let me just copy this line and change it to mouse y. So this might be a bit confusing to some of you because we are adding mouse y to rotation x and mouse x to rotation y, right? But the reason for this is because for horizontal rotation, we should rotate around the y-axis, and for vertical, we should rotate around the x-axis, right? So if that's confusing to you, take a minute or two to think about it, and you'll get a hang of it. All right, so let's continue with the vertical rotation. So here, I need to add the rotation x to the x of the Quaternion.Euler. And now we should also be able to rotate the camera vertically. All right, let's go ahead and test it. So now if I move my mouse up and down, you can see that we can rotate the camera vertically. Okay. But in the case of vertical rotation, we want to clamp it to some limit, right? We should not be able to rotate all the way around the character like this, right? So we should set a limit to how much we can rotate vertically. All right. So we can easily limit that by clamping the rotation x value. So to clamp a variable, we can use mathf.clamp. And what this function will do is it'll take a min and max limit. And if the value goes beyond the limit, then it'll just clamp the value to the limit. So in this case, rotation x is the value that we want to clamp. And then we should define the min and max limit. So I'll create variables for the min and max limit, and I'll make them serialized field so that we can tweak it from the inspector. Okay, so I'll call the first variable min vertical angle, and let me set it to something like -45 by default. All right, and then I'll duplicate this line. And by the way, you can duplicate a line in Visual Studio by using the Control D shortcut. All right, so I'll duplicate the min vertical angle variable and create another one called max vertical angle. So I'll set this one to plus 45 degrees. All right. So now we can clamp the rotation X between the min vertical angle and the max vertical angle. Okay. So let's go to Unity and test this. And by the way, I'll just make sure that the min and max angles are correct in the inspector. And I'll go ahead and play the game. Okay. So now I can't move the camera above this limit. I'm clamped over here. And if I go down, okay, this minimum angle is a bit too much, but I'm clamped over here. I can't go beyond this point, right? So the clamping is working properly. So we're done with the vertical rotation, but there is actually a problem. Right now, the camera is actually looking at the bottom of the player, right? It's not pretty obvious right now, but when you bring in an actual character model, the camera will be looking at the feet of the model, and that'll look really weird. So the camera should actually look at the chest or the head part of the player. So we can easily achieve that by adding an offset to our target position. So here I'll create a new vector2 variable and I'll call this framing offset. Okay, and then instead of using the follow target dot position directly, I'll add the framing offset to the follow target position. All right, and let me store this in a variable called focus position. So this is the position to which the camera should focus. Okay, we can't simply add these two like this because follow target dot position is a vector 3 and the framing offset is a vector 2, right? So we can't directly add them. So here I'll have to create a new vector 3 and then I'll have to pass framing offset dot x and framing offset dot y. Okay, so that solved the error. And now we have focus point. So here, instead of using the follow target dot position, I'll use the focus position. So let's go to Unity and test this. All right, so right now it's still looking at the bottom because we didn't set the offset in the inspector. So let's try changing the framing offset from here. So here you can see as I increase the Y offset, our focus position gets higher and higher, right? So let me just set it to a value like 1 for now. We'll adjust this further when we bring in an actual character. All right, so that looks much better. So next we also need to limit the minimum vertical angle. This is a bit too much. We should not be able to go below the ground, right? So let me try setting it to something like -20. And by the way, here you can see that the framing offset has been reset to 0. This is because we changed its value when we were in the play mode, and whatever changes that we make in the play mode will always be reset when we exit the play mode. All right, so let me set it back to 1. And now let's go ahead and test if the vertical angle is fine. So yeah, that's okay. So now we are done with the vertical and horizontal movement of the camera. All right. So there is one more thing I want to add before I stop the video. So I want to be able to control the speed at which the camera moves. So that is pretty easy to achieve. When we are updating the rotation X and rotation Y variables from here, we can multiply the mouse input with the speed value. All right. So here I'll create a new float variable called rotation speed. And let me just set it to 2 by default. Okay. And then I'll just multiply the rotation speed with the mouse input. All right. So let me also do it in this line. Okay. So now we should also be able to control the rotation speed of the camera from the inspector. All right. So it's 2 right now, but if you want, you can increase it to a higher value. So next, I want to hide the mouse when we are playing the game. So right now, you can see the mouse when the game is being played. So I want to hide that. So to hide the mouse, we have a property called cursor.visible. So I'll set that property from the start function. So let me create the start function over here. And in the start function, I'll set the cursor.visible property to false. So this will make the cursor invisible. And then we can also lock the cursor by setting cursor.lockState to cursor lock mode dot locked. Alright, so now we won't see the cursor when we play the game. Alright, so you can see that the cursor is not visible anymore. And now if you want to stop the play mode, you should first press the escape key. So this will make the mouse visible again, and then you can go ahead and stop the play mode. Alright, so just keep that in mind. So now we have a decent third-person camera, but there's one more thing I want to add. So some people prefer the camera direction to be inverted, right? So let's add a setting for that in our camera controller script. So here I'll add two new Boolean variables. So the first one will be called invert x, and the second one will be called invert y. So if the invert x is true, then we should invert the x rotation. So we can easily do that by multiplying the mouse input with -1, right? So what I'll do is I'll create two more variables for the invert value. So first one will be called invert x val, and the second one will be invert y val. Okay, and we'll set its value from the update function. So if the invert x is true, then the value will be -1, and otherwise the value will be 1. All right, so let me store this into invert x val variable, and then I'll also do the same for the invert y val. All right, so now we can multiply the invert x val with the mouse x input, and we can also multiply invert y val with the mouse y input. Okay, so this should allow us to invert the camera movement. So from the inspector, I'll turn on invert x and invert y. All right, so now when we test, the camera movement should be inverted. All right, so now we have a basic third-person camera setup. So I'll stop the video here, and in the next video we'll implement character movement.